everyone, my name is Manisethi. I hope you all are staying healthy. Today we are going to talk about concept of a limit. For example, in this question we set a limit x approaches 3 or you can say that x tends to 3. That means in place of x we will put 3 and we'll get our fx equal to 6. We can simply get fx by putting x equal to 3. Then why we need to use concept of a limit? Here we have another question. Suppose we simply put x equal to 3, then our denominator will become equal to 0. As we know, if denominator is 0, that means our function is undefined. In order to make our function defined, we use concept of limit. That means now we will approach to 3 rather than directly calculate a value. Approach to 3 means value of x will close to 3. It can be greater than 3 or less than 3 but not exactly equal to 3. For example, x approaches 0 or you can say that x trend to 0. That means value of x is close to 0 but it not exactly equal to 0. It can be greater than 0 like 0.1 or 0.01 or it can less than 0 like minus 0.1 or minus 0.01 but it will not exactly equal to 0 because now we are approaching 0. So in order to approach any value or make our function defined, we use concept of a limit. So we mainly use concept of limit in case of undefined function. For example, 0 into infinity is not defined, 0 over 0 is not defined, infinity over infinity is not defined, similar infinity into minus infinity is not defined. If our answer will come in any form, then we will change it. That means through limit we try to make our function undefined to define. Now we will see direct substitution method for limit. X approaches 2. In place of x, so we will put 2. Then our function will become equal to 14. If x approaches 2, then our function will become equal to 14. Similar, if x approaches 0, then our function will become equal to 1. Direct substitution method is very simple, there is no problem. Now we will see factorization method to find a limit in indeterminate form. This is our question. X approaches 1. First of all, we will try direct substitution method. Means we directly put 1 in place of x. So here you can see our function become undefined. Now we will simplify this through factorization. So now x square minus 1 square over x minus 1. So we can write x plus 1, x minus 1 over x minus 1. As we know, a square, b square equal to a plus b and a minus b. So this cancel out, x plus 1. Now we will put 1 in place of x. So now our function become equal to 2. If x approaches 1, then our function become equal to 2 through factorization method. Now we will see one more question with factorization. X approaches 2. First of all, try direct substitution method. If you directly put 2 in place of x, then denominator will become equal to 0 and our function is undefined. Now we have to do factorization method. We do factorization 2x square minus 5 will become equal to 4x minus x plus 2 over x minus 2. We will take 2x common, it will become equal to x minus 2. We will take minus 1 common, it will become equal to x minus 2 over x minus 2. It will become equal to 2x minus 1, x minus 2 over x minus 2. This will cancel out each other, 2x minus 1. Now we will put 2 in place of x. Now our function become equal to 3. If x approaches 2, then our function become equal to 3 according to factorization method. Now we will see one question when x approaches infinity. Here first of all we will try direct substitution method. Directly in place of x we put infinity, then our function become undefined. So now we will simplify this. That means we divide upper and lower side with x. It will become equal to, we divide upper and lower side with x, it will become equal to x plus 1. Now in place of x we put infinity. In place of x we will put infinity. As we know, any number by infinity will become equal to 0. So our function will become equal to 1. When x approaches infinity, then our function will become equal to 1. Now we are going to talk about rationalization method. Rationalization method we mainly use in case of root because we can't do factorization. So here x approaches 0. First of all we will try direct substitution method. If we directly put 0 in place of x, denominator will become equal to 0 and our function is undefined. So now we will apply rationalization method. In order to apply rationalization method, we will divide and multiply this function with square root of 1 plus x plus 1. So this is our function, and we divide and multiply this function with square root of 1 plus x plus 1 and square root of 1 plus x plus 1. This is a, this is b, this is a and this is b. As we know, a minus b and a plus b is equal to a square minus b square. So this one become equal to this and this one become equal to this, and below we have this one. So here you can see this cancel out and it will become equal to this. So this cancel out, this also cancel out, and our function will become equal to 1 plus x plus 1. Now in place of x we will put 0. When we put, as we know, square root of 1 is equal to 1. So this will our answer. When x approaches 0, then our function will become equal to 1 over 2 according to rationalization method. Now we will see one economics question with the limit concept. Cost function of firm is 50 plus 2q. Total cost of firm is equal to 50 plus 2q. 50 fixed cost, 2q is a variable cost. And we have to find out long run average cost when output become extremely large. Output become extremely large means output approach to infinity. So first of all we will calculate average cost. As we know, total cost divided by q is equal to average cost. Total cost function is this one divided by q. We can write this like this. So here you can see cancel out. This will become equal to this. This is our average cost, and we have to find out long run average cost when our output approach to infinity. So in place of output, in place of q we will put infinity. So 50 divided by infinity become equal to 0. Our answer will 2, means when output will become extremely large, then our long run average cost become equal to 2. So this is all about concept of limit. I think you got it, and thank you so much for watching this video. Bye, take care.